Have you ever stopped to think about what your refrigerator and a global weather forecast could possibly have in common? I know, it sounds like a stretch, right? But today, we're going to pull back the curtain on a surprising connection, a hidden world of cold data that actually starts right there in your kitchen and scales up to, well, the entire planet.
So let's kick things off with a little riddle. What's the one thing that connects food poisoning, a really tricky programming puzzle, and tomorrow's weather forecast? The link isn't obvious at all, but believe it or not, it all comes down to temperature and the story that data tells us.
All right, so here's our game plan for this journey. We're going to start with the simple rules of your fridge. Then we'll see how it's secretly a data sensor. After that, we'll dive into the science of the danger zone, solve a really fascinating math problem that pops up all the time in data reporting. And then, for the grand finale, we'll scale everything up from your kitchen to the whole world.
Let's start with the basics, right there in your kitchen. You know, we all think of the fridge as just a cold box, but it's really a precision safety device, and it operates on a few very important rules. It really all boils down to three core principles. First, you've got to keep it at the right temperature. Second, you have to arrange your food in a very specific top-to-bottom order. And of course, third, you got to know when it's time to just toss something out. Each one is super important, but let's really focus in on those first two.
Okay, that first rule. There is a magic number in food safety, 5 degrees Celsius, or 41 Fahrenheit. Your fridge has to stay at or below this temperature. It is the single most important line of defense you have against getting sick from your food.
Now here's where it gets really interesting. That second rule, how you stack your food. It is not random at all. The idea is to put the foods that need the highest cooking temperature at the very bottom, and the stuff that's ready to eat at the very top. So why do we do this? Simple, to stop cross-contamination. If raw chicken juice, which, needs to be cooked to 165 degrees, drips onto a salad that's on a lower shelf, you've got a big problem. This system is just a brilliant way of using gravity to keep you safe.
Okay, so let's completely shift our perspective for a minute. Your fridge isn't just a box for food anymore. In our modern world, it's actually something else entirely. It's a data-generating sensor. A smart fridge is constantly creating this stream of temperature readings. Each of these numbers is a data point, and each one is telling a story. You see readings like 4.7, and you know everything's good. But then you see a 5.2, or even an 8.0. Whoa, those are warnings. Those are signals that there's been a breach in what's called the cold chain, and that's a critical failure in food safety.
So why is a reading of 5.2 degrees such a massive deal? I mean, it sounds so close, right? To really understand that, we need to dive into the microbiology that's hiding behind that 5-degree rule. And this brings us to a core concept in all of food safety, the temperature danger zone. This is the specific range where harmful bacteria, we're talking Salmonella, E. coli, basically throw a huge party and multiply at a truly alarming rate. And that party gets started right above our magic number of 5 degrees Celsius.
Just stop and think about what that means for a second. The growth isn't slow and steady, it's exponential. A single bacterium can turn into thousands and then millions in just a matter of hours. The second food enters that danger zone, a clock starts ticking, and it's ticking fast. So you can see it's this delicate balancing act. If it gets too cold, below freezing, ice crystals form and just wreck the quality of your fresh food. But in that sweet spot, between 0 and 5 degrees, that's where you have optimal safety. The moment you cross that 5-degree line, though, you're in the red zone, where these pathogens can just multiply completely out of control. Okay, so we have our data stream, and we know which readings are good and which are bad. The next logical step is to report on it, right? But this is where a really simple question leads us down a rabbit hole into a fascinating mathematical puzzle.
So how do we actually report on this? We want to know, hey, what percentage of the time is this fridge failing? We can calculate the exact percentages, no problem. But to make a nice clean report, we need to round them to whole numbers. Sounds simple enough, right? Well, it's really not.
And here is the problem. If we just use the standard rounding rules we all learned in school, our percentages add up to 101%. That doesn't work. So you think, okay, fine, I'll just chop off the decimals. That's called truncation. But if you do that, they add up to 97%. That's also wrong. So how in the world do you round these numbers and make sure they still add up to exactly 100?
The solution is this really elegant algorithm. It's used in data science, and kind of interestingly, it's also used for assigning seats in some political systems. It's called the largest remainder method, and it guarantees you get a perfect 100% total every single time.
Here's how it works, in 3 easy steps. First, you just round all the numbers down. So in our example, that gives us that total of 97%, meaning we're short by 3. Second, you look at your original numbers and you find the 3 that had the biggest decimal parts, the largest remainders. In our case, that was the numbers ending in 0.98, 0.78, and 0.62. And finally, you just add 1 point to each of those 3. And just like that, you have rounded numbers that perfectly add up to 100. And it's as fair as it can be, because you're rewarding the numbers that were closest to being rounded up anyway. Pretty clever, right?
And now for the final leap. We've gone from food safety to data science. Let's take everything we've learned from this one little fridge and apply it on a global scale.
This is where it all clicks into place. Think about your smart fridge. It's like a tiny weather station. It has one sensor, it's monitoring one small box, and it's producing maybe a few dozen data points a day. Now, imagine scaling that up to MADIS. That's the Meteorological Assimilation Data Ingest System. This is a network that uses millions of sensors to monitor the entire planet, and it processes billions of data points every single day.
And the sources for all this data are just incredible. We're talking about temperature readings from commercial airplanes flying overhead, from weather balloons floating up in the stratosphere, from satellites that are tracking wind from space, from buoys just bobbing around in the ocean, and even sensors that are measuring the depth of snow on the ground. It's this staggering orchestra of data from thousands of different instruments, all feeding into our weather prediction model.
But here's the beautiful insight. The core challenge is exactly the same. It doesn't matter if you're managing one fridge or you're trying to forecast a hurricane. It all boils down to this. You have to collect massive amounts of data, you have to ensure its quality, and you have to report on it accurately. Even using tools like the largest remainder method to make sure it all adds up and makes sense. So we're left with this one final thought. We've just seen the complex science and the data challenges that are hidden inside a single, ordinary refrigerator. So if one small box in our kitchen is this intricate, what does it truly take to understand and to predict the behavior of an entire planet? It's a pretty fascinating thing to think about. Thanks so much for joining us.